Everyone, welcome to SmartSpark Academy. Today we'll be talking about organic chemistry. We're treating IUPAC nomenclature of organic chemistry. So IUPAC nomenclature is the standard way of naming organic compound. You get. So if you look at this compound, if I ask you what is the name of this compound, it's looking complex. This is looking complex. Now, because of that, we'll be starting from the foundation. We'll start from the foundation of nomenclature of organic compound. So follow up. Thank you very much. Watch till the end so that we'll be able to name this compound. All right. Starting from the foundation of organic chemistry is to know how to name simple bonds. That's alkenes. Alkenes, A-N-E at the end, alkenes. Okay, so we have, what are alkenes first of all? Alkenes are saturated aliphatic hydrocarbons. This is the main word, saturated aliphatic hydrocarbons. Hydrocarbons are then organic compound that possesses only hydrogen and carbon atom. Hydrogen and carbon. Now, then aliphatic compounds are compounds that don't have what? Benzene ring. Now, when I drew that stuff at the beginning, at the initial, that compound can be referred as aliphatic compound because of there's no benzene ring. Now, what is a benzene ring? The benzene ring is something like this. Benzene is a compound. So when it appears in two ways. You can write it in two ways: the resonance form and the stable form. So this is the stable form. This is the benzene ring. Write it like this. Draw it like this. Sorry. And put something like this. Put something double bond. Then know that this, when you're putting a double bond, you know that it resonates. It resonates. Something like this, 1, 2, and 3. So this example of what? This the structure of benzene. So aliphatic compounds do not have what? Benzene ring. They can be straight chains, they can be branch chains, but basically they are what? They don't contain what? They don't contain benzene ring. Then now let's move further. Alkanes are also called paraffins. They have the general molecular formula CnH2n plus 2. Note this is very important. CnH2n plus 3. Now let's take, for instance, let's C be equal to 3. When C is equal to 3, 3 times 6, 3 times 2 is 6. 6 plus 2 is 8. So CnH8. This is what? Propane. So this is an example of what? An alkane. Now, if you go further, where N is the number of what? Atom present, carbon atom present. Now, therefore, alkanes are classified as what? Homologous series. Homologous series are organic compounds, family of organic compounds that share a general molecular formula in which one member differs from the immediateness by CH2. This the all mass 14. So if you are to check the next member will be addition of CH2 to this propane. So if you minus CH2 from this propane, it will give you the first one. So each member differs from the immediateness. Put that word immediateness. Let's take now, for instance, butane. You can just say butane is C4H10. This is butane. The next member. I'll give you a list of the members of alkane, moving from the first one, when it's just C1, when it's C2, when it's C3, when it's C4, when it's C5, and it's C. You understand now? So that is why they are classified as what? Homologous series. You understand? Family of organic compounds that have a general molecular formula. This one has a general molecular formula in which one member differs from the immediateness by what? CH2 or what? Mass 14. So moving further, we'll be discussing about the characteristics of homologous series. All right, going further, general molecular formula of alkane is what? CnH2n plus 2. I want to experiment this now. When n is equals to 1, you put 1 here. So 1 times 2 is 2 plus 2, 4. This is what we call methane. This is methane. The structure of methane now will be determined by this stuff you just discovered. C, 1C, 4H, 1, 2, 3, 4. Make sure you put your H. Don't leave it like dash. You understand now? So the next one now is When n is equals to 2, let's check. 2 times 2, 4, plus 2, 6. So this compound is called ethane. So to draw the structure of this compound now, we have two carbon, C and C. Now, how many hydrogen are to be placed in each C? 6. 1, 2, 3, 4, 4, 5, 6. This is a line. This is a bond. This is a bond, a single bond joining these two C's together. So we have 1 hydrogen, 2 hydrogen, 3, 4, 5, and 6. That's what 6 hydrogen. Same thing with this. This compound is called propane. Propane is called propane. Now, C3, 3 times 2, 6 plus 2, 8. If you subtract this from this, you get C2. If you subtract this from this, you get this C2. That is that homologous series we are talking about. Each member differs from the immediateness by what? CH2. You understand? Or mass 14. Now, going further, this is propane. The same thing. This is butane. So when it's 4 is butane. When it's 5 is pentane. When it's 5 is pentane. When it's 6 is hexane. You can try for 6. When it's 7 is heptane. etc. That's when it's 8 is octane. When it's 9 is nonane. etc. Then moving further now, we'll be talking about the homologous series, the characteristics of homologous series. Now we'll be comparing. Now, these are the characteristics of the homologous series: general formula, similar chemical properties, similar method of preparation, nomenclature, and physical property. Now, any compound or group of compounds that are found under this homologous series, that are classified as this homologous series, they will have something. I told you alkane has general formula. Can you remember the general formula? CnH2n plus 2. That means alkane. That means alkane is a what? Homologous. Let's go further. Similar chemical properties. Now, for chemical properties, alkanes are saturated. So their main they will not undergo addition reaction. They will undergo substitution reaction. You understand me? So that reaction now is same for all alkane. Same chemical reaction. You can also add combustion. You can also add combustion. So combustion reaction. This combustion reaction is the process in which you burn an organic compound. Let's take for instance alkane and alkane. Burning an alkane in presence of oxygen, that's burning, will give you carbon 4 oxide and what? Water. Carbon 4 oxide and water. So this is a property of what? So this is characteristics of homologous series, relating it with what? Alkane. Now let's go further. Similar method of preparation. While preparing an organic compound, sometimes for alkane, you can prepare it by mixing metal carbide. Like let's say metal carbide. Metallic carbide. Now, to prepare similar preparation, I was saying you can mix a metallic carbide with water. This is a metallic carbide, aluminum carbide, with water to give you a product. This is a product. The product here is Aluminium hydroxide plus an organic compound, and that organic compound is an alkane. If you see it, this alkane has one C. That means this is a methane. This is how methane is produced. Mixture of aluminum carbide with water. If you want to get other compounds under alkane, you can also change, maybe possibly change the compound there, the carbide here. It may be zinc carbide, calcium carbide, to give you another what? Organic compound. You understand me now? So let's move further. Nomenclature. Now, in nomenclature, all alkanes ends with ANE. If you are moving further, alkane, when we're talking about alkane, all alkanes ends with ENE. You understand me now? So that is what homologous series, nomenclature. Every compound under this thing must follow that order. Alkanes, ANE. Now for physical properties increases as you progress. Let's take for instance methane, ethane, propane, butane, etc. The physical properties increases, like density can increase, boiling point can increase, melting point can increase, etc. Now we'll be moving further to the aspects where we'll be what? Naming. That's the nomenclature. Now, when we'll be talking about the nomenclature, we'll be talking about the rules and regulations on how to name. When you know these rules and regulations, you'll be able to name any compound. Let's proceed. My belly is spinning. All right. While naming an organic compound, these are the 4 rules to follow. Very simple. The longest continuous, number 1, the longest continuous chain with the highest number of branches is chosen as the main chain. When we proceed with the examples, you understand. I will be using it as we go on. Now, number 2, substituents and branches are considered. Now, when naming, if you see a substituent like chlorine, now if you see Cl, when you see chlorine, it's not be called, in organic chemistry, chlorine is not called chlorine, it is called chloro. Bromine is called bromo, etc. Now for alkene, for number 3, alkyl group are to be considered usually in branch chain. Now what are alkyl group? Alkyl groups are alkanes that lost one hydrogen. Now you know we have methane. The structural formula of the formula for methane is CH4. When this methane loses one hydrogen, it becomes methyl. So the next one now will be, if propane or ethane loses one hydrogen, ethane is C2H6. Now if it loses one hydrogen, it will be C2H5. Now it will be called ethyl. Now the next one, propane, it will be called propyl when it loses what? One hydrogen. Butane, etc. will be called what? Butyl. You get me? Now moving further, the next one is 4. When naming, you notice a digit, you separate the digit from the words. Let's say we have 4 butyl, blah blah blah. So we have 4 methyl. The methyl will be separated from the 4 with this dash. You get? Then the last thing is, then at the end, when naming, the suffix, if it's an alkane, you put ANE. Now there's a question on the board. There's a compound on the board. It is name this compound. Now to name this compound, the first thing you should understand that this C3 here and this C3 here can be expanded. Any C3 you see can be expanded, but if you wish. All right, to name this compound on the board, the first thing we should do is to locate the longest continuous chain. The longest continuous chain. So if you go like this, this is 1. How do you know the longest continuous chain? The carbon will direct you. Carbon 1, carbon 2, 3, 4, 5. If you go like this, you will see 5 carbon in a row. If you go like this, 1, 2, 3, the chain ends here. Only 3 carbons. You cannot do 1, 2, 3, 4. No. Just like a water pipe. If you move straight, the water will move straight. If you move like this, the water ends here. You understand me? Now let's check this other chain. We have 1, 2, 3, 4, 5, 6. This, when we are moving this way, we had 5. When we moved like this, we had 3. When we move like this, we had 6. So from the first rule, the longest continuous chain here is what? This chain. So we'll be using this chain like this. So this is the chain we'll be using. That's the number 1. So we have identified the longest chain. So the longest chain gives us the first thing: 1, 2, 3, 4, 5, 6. So this compound is hex. Hex. Now, because of its only single bonds that are here, it is what? Hexane. Hold on, we are not done. Hexane. Now we have some substituents attached here, some little attachment here, some little attachment, because we follow this chain like this. So this one will be the attachment. This is the first attachment, substituent or branch. This is second, third, fourth. You understand? The second rule says we should locate the branch or the substituent. The branch or the substituent. Now we have one substituent, 2. Then these are the branches. Now, if we follow 1, 2, you can follow 2 ways. You can follow 1, 2, 3, 4, 5, 6. You can also follow 1, 2, 3, 4, 5, 6. Anyway, neither left or right, anywhere you want to go. But you should just note the flow. Now, for the flow of this one, if we follow like this, we have 1, 2, 3. We meet the first branch here. I told you a methane that lost one hydrogen, CH4, that lost one hydrogen will be CH3. So it will be what? A methyl. So this is what? A methyl. Note, is a methyl. And where is it located? It's located at the third carbon. 1, 2, 3. Methyl. Third carbon. Hold on. We are not done. So you can just put it one place. 3 methyl. Just hold it one place. Then we have 1, 2, 3, 4. At 4, position 4, we have bromo. That's bromine. 4 bromo. 4 bromo. So at 4, we have bromo. 4, we have bromo. 5, we have 2 things. We have fluoro and what? The normal methyl. So at 5, fluoro. Then if you go down, you still have a methane that's lost one distance. So it's methyl, lost 100 hydrogen. So we have 5 methyl. Now with all this information, we have found the compound. We have found the name of the compound. Remember, 4 bromo. The next thing we have there is what? 5 fluoro. After 5 fluoro, we have 3 methyl, a number and a number. 3 and 5. 3, 5 methyl, a number and a number. You separate them with a comma. A number and an alphabet. A number and an alphabet. Separate them with okay, I'm making a mistake here. 5 fluoro. You get a number and an alphabet. Separate them. 5, okay. 4 bromo, 5 fluoro, 3, 5 dimethyl what? Hexane. So this is the answer to this stuff. So if you tell somebody is 4 bromo, they will put the bromo at the 4th carbon. 5 fluoro, they will put the fluorine at the 5th carbon. 3, 5 dimethyl, 3, they will know that okay, the methyl is at carbon 3. 5, the methyl is at carbon 5. So that's just the this thing of what? Organic chemistry. If they give a chemist this word, 4 bromo, 5 fluoro, 3, 5 dimethyl hexane, he can identify where they are with just the word, with just the name. So sometimes they can give you this one to what? Form the structure. You understand? We'll check out the next question now. All right. For the next question, exactly what I just said. They can give you the words to form the structure. So we have 3,3-diethyl. Listen, ethyl is an ethane that lost one hydrogen. And ethane is what? C2H6. Ethane is C2H6. So when the ethane loses one hydrogen, it becomes what? Ethyl. ethyl. So 3,3-diethyl pentane. The first thing you will do is to identify the longest chain. The longest chain here is pentane. So we have 1, 2, 3, 4, 5. Remember, pentane is what? Pentane is 5. Pentane is 5. So going further, you add the single bond that attaches them. So they said 3,3-diethyl. So 1 carbon 1. So all of them, the 2 ethyl are carbon 3. 1, 2, 3. So we have CH, C2H5, C2H5. The rest has one hydrogen. This has 3 hydrogen. Then as simple as that. As simple as what's that? 3. For number 2. Note, you don't start, you will expand this stuff. To expand this, note something. We have chlorine, we have carbon. This carbon is attached to 2 hydrogen, so you can leave it like this: hydrogen, hydrogen. You understand? This dash is this bond, this single bond continues. Then the next chlorine, see how you do it here. Carbon first, then the carbon is attached to 2 hydrogen. You can leave the 2 hydrogen here, 2 hydrogen here. We have chlorine, you can put the chlorine here. You can exchange any of this stuff, but this is more okay. This is better to be used. Now, if you continue to name this thing now, there is chlorine here in the first carbon, there is chlorine here in the second carbon. If you follow like this, it will be chlorine in the first carbon, chlorine in the second carbon. Now listen, the first rule says you must find the longest chain. The longest chain is this and this. So this and this is what? Ethane. Ethane. That's the first things first. Then there are substituents attached to it. The substituent attached to it is chlorine. Now locate where the substituent is attached. So carbon 1, chlorine is attached. There's 1 chlorine attached to it. Chloro. Carbon 2. Carbon 1, okay, this is carbon 1, there's 1 chlorine attached to it. Carbon 2, there's another chlorine attached to it, chloro. So this is called 1, 2, 1, you put comma, 1, comma, 2, dichloro what? Dichloroethane. This is the answer for this question. First, you will expand it by this. You find the longest chain, locate the substituent, then name it. That's 1,2-dichloro what? Ethane. All right. The last part we are talking about, this is the part that will likely come out in your exam. Cycloalkane. Now, when you are talking about cycloalkanes, look. 1, 2, 3. How many carbon here? 3. So it's what? Propane. No double bonds, it's just single bond. This is propane. Now, to note, to show that it is cycloalkane, you just add cyclopropane. This is what? Cyclopropane. Circular form or linked together, they call it cyclo. Linked together, they call it cyclopropane. So if you look at this one, we have 1, 2, 3, 4. 1, 2, 3, 4. This is butane. Because of it is linked together, cyclo, you put what? Cyclobutane. Sorry, this is a small p. So here is what? Cyclobutane. Simple. Now, there's a part that comes out also in your exam, something like this. There's a part that comes out in your exam. Now, this part is just like a skeletal form of the compound. They can leave the compound in this form. You can just say, name this. Now, for you to name this, the edges are where the carbon are found. We have C here, C here, C here, C here, C here, C here. Simple. Sometimes I've seen a question like this. Name this compound. Very simple. 1, 2, 3. Now, to name this compound first, you do 1, 2, 3. This is the longest chain. You can do 1, 2, 3. Still longest chain. So 3 is the longest chain in this compound. So these other ones are substituents. So we have 1, 2, 3. Propane. So two Two what are attached? Two CH3. CH3 is what? Methyl. Methyl. Alkyl, that methyl, methane that lost is methane that lost what? One hydrogen becomes methyl. So we have two. So this is 1, 2. We have 2, 2 di So we have 2, 2 dimethyl propane. So this is the answer to this question. Now to this question here, we have 1, 2, 3, 4, 5, 6. In 6 and its single bond, it is called what? 6 and its single bond is hexane. So the answer for this is what? Hexane. Simple. So with this, we have come to the conclusion of IUPAC nomenclature of what? Alkanes. IUPAC nomenclature of alkanes. Make sure you like, subscribe, and comment on the comment section the parts that stood out while learning with us. Thank you very much.